Dear friends, I am Linus. Last couple of classes, two classes, we have learned about the history of electrical vehicle and why we need to go for electrical vehicle and different things, manufacture everything in the first lecture. Then second lecture, we have learned that a buck converter controlled electrical vehicle with battery operated. How one can do the closed loop control by using MATLAB Simulink, and what all the output has come when the torque changes, what is happening, and when that duty when we change the reference speed, how that outcomes are, and the current, voltage, torque and all. Also we have learned how one can convert that rpm to that kilometer per hour when we use for electrical application. So electrical vehicle applications. So in this lecture, I am going to explain the regenerative braking. So as we know, the regenerative braking is very much useful for an electrical vehicle applications, especially when the car is coming down from the hill area, top to coming down from the lower level. If we see that car, it will be in that, if you see that normal our conventional car also, petrol or diesel car, if you make it neutral and run the car, that fuel consumption, even though if you give a gear, that fuel consumption will be very less. You can see the kilometer indicator, you can come to know the fuel indicator, that the fuel consumption will be very low. That means we no need to give any power to rotate the vehicle. So due to the slope, it will automatically rotate. So normally we will brake the vehicle, apply the brake, and we will waste the power in terms of heat, resistive loss. So in electrical vehicle, people are doing whatever the power it is generated. That time motor will act as a generator, and we can store the energy to the battery. So that is called as regenerative braking operation. So in this lecture, I am going to explain this for with the MATLAB simulation, so that you can understand well whatever I am going to explain. So let me share my my presentation. I hope you can see my view, my desktop. So now this is the title of today's presentation: regenerative braking for electrical vehicle. So just I have summarized what are the things in the last two lecture we have completed. Why we need to go for electrical vehicle, disadvantages of IC engine based vehicle, and advantages of electrical vehicle, history and development in electrical vehicle, simulation of buck converter closed loop for electrical vehicle applications, then calculation of speed from RPM to kilometer per hour. So these are all the things we have learned in the last two lecture. So in this case, we should know the basics, how one can understand the regenerative braking. For to understand the regenerative braking, so in these normal cases, we have one battery in electrical vehicle. So electrical output will be the DC, so positive, negative. Then we are giving to power converter and the control. Then output, I am assuming it as three-phase output. Then we are connecting to motor or generator. I will let you know when it will be motor, when it will be generator, after completing this entire block diagram. Then output is given to the transmission. The transmission having axis, that axle connected to the tire. So this is the normal power flow. Power flow is happen from battery through power converter, motor, transmission, and giving to the tire. So this is the normal power flow. So when what I have explained during the starting, when the car is moving through the slope, coming down to the slope, what will happen? We have to apply, the tire will move fast. The car wheel will move fast. So that movement has been converted into electrical quantity by using generator. So that time this machine will act as a generator. Then that output is AC, then given to power converter. The power converter which will control it and giving to the battery for storing purpose. So when during the driving mode, battery safe operating point which will reduce, battery state of charge will start to reduce. So during regenerative braking, what happened? Power flow is in that opposite direction. That is a red line I have shown. Then power is coming to this battery. Though this time that battery will, the state of charge will start to increase. So this is the difference. So previous cases, last class we have learned done buck converter, that is called as drive mode. Today I am explaining only regeneration mode by using simulation output. So in this case, instead of wasting the power by applying brake and waste in the form of heat, just we are generating the power and feeding the power to the battery for and storing it. That is called as regenerative mode. So in this about this regenerative braking, that whatever I summarize, whatever I told, just I am summarizing. Conventional braking has friction. That is why due to that heat will generate it. That is a waste of energy. That is why people have introduced regenerative braking. Then next one, it will perform in certain speed only, effectively in certain speed only, because it is very much slow when compared with normal braking. So that what it will do, it will assist the regular braking system. At any cost, regenerative braking fails, the controller will activate the conventional one. So in any very electrical vehicle, as of now, we have regenerative mode of braking as well as normal conventional mode of braking, so that at least if any issue comes, automatically controller give the response and accordingly that conventional one will act. So this is the conclusion behind this regenerative braking. So then as we know already, we used to do boost converter. Boost converter for regenerative braking. Kindly go through the basics of boost converter. I am not going to explain any basics of boost converter. Directly I am going to the simulation part. So the parameters I have used: separately excited motor 5 HP. Same parameters I have used for the buck converter control: 5 HP, 1750 RPM, 240 volt, field supply 300 volt, then battery 240 volt, 15.5 ampere hour. I have explained in the last class how I have chosen this battery and the ampere hour and all. Then third one, MOSFET only I have used, switching frequency 5 kilohertz. Then boost converter. In this boost converter, we know terminal voltage of the motor. We can write the formula. We know terminal voltage is equal to supply voltage into 1 minus duty cycle. Vs, sorry, this is wrong. Vt is the terminal voltage. There is a mistake. Then Vs is the supply voltage, Vt is the terminal voltage, and del is the duty cycle. Then power during the braking, power transferred to the that battery can be rated as terminal voltage into I alpha. So with respect to duty cycle, automatically the terminal voltage will vary. That means as long as terminal duty cycle is increasing, if the duty, for example, my duty cycle is 0.8, what happened? That Vt is equal to 0.2 into Vs. When duty cycle is 0.2, Vt is equal to 0.8 into Vs. So terminal voltage increases as long as we are reducing the duty cycle. As long as we are reducing the duty cycle. So when we reduce the duty cycle, our power transferred to the battery is more. If we increase the duty cycle, power transferred to the battery will be less. So the reason behind this is, we know the circuit that buck converter, boost converter, that switch is chopper is connected parallel to the diode, parallel to the line, so that during on time it will be storing. Inductor will store energy. Then when we'll open it, power will be feedback to the load through the diode. So now just let me know, just I am going directly to the MATLAB. This is the MATLAB thing, whatever I have done. All the parameters I have already explained in the last class. Why I have chosen inductor, why I have chosen capacitor, and inductor is same 5 millihenry, capacitor is same 150 microfarad, then switch it is in parallel, then diode, then I have connected here battery we can get state of charge, you can see, then voltage and current. Now I am assuming for a better understanding in this battery, when compared with the last buck converter, I have fixed this initial state of charge is 50%. The reason is I need to charge it. That's why charge is come down 50%. Then remaining things are same. I have connected. This is open loop only. So initially, what I am going to do is just simulation time total 10 seconds, out of which till 0.6 initial value of duty cycle is 0.6 till 3 seconds. Then initial value, final value will be 0.8 from 3 to 10 seconds. Final value will be 0.8 duty cycle. Then load torque, the load torque till 7 seconds, load torque is full load torque minus 20. Why minus 20? It is act as a generator. Then from 7 to 10, that final value is minus 5. Then power calculation, I have taken this voltage and current across this switch and connected to the mean value for switching on, switching off. Maybe it is having we cannot get clear waveforms, that is why I have connected mean value. Then product I have connected to the scope. So this is the output of this output scope. Let me run the simulation for 10 seconds. So in this 10 seconds, so what happened? Due to speed is increasing, speed is increasing, then armature current is negative. The reason is direct, previously buck converter armature current is positive, here current feeding is negative, that is why negative, but field current is as same. Then electromagnetic torque is also negative, the reason is it will reflect armature current. Then this case I have connected the torque and duty cycle. Just I am giving now duty cycle is 0.6 and torque is 20 minus 20. See at, let me see at 3 seconds. 3 seconds what we are going to do, just we are changing the duty cycle. Yeah, duty cycles we are changing to 0.8 seconds. So as the duty cycle changes, what happened? As the duty cycle is changes, increases, what happened? Power on time of switch is more. That time what will happen? Speed will come down. Current drawn will be more. The speed will be come down. That is why 100 approximately 100 RPS. Then armature current, only there is a dip in armature current in order to reduce the speed. Again, it will reaches to normal armature current. Then electromagnetic torque is also reflecting the same. Field is also same. Field is, we are not doing it. This is separately excited motor. Field current is same. Then again we are going to change this. Then again we are changing the torque at 7 seconds. If we change the torque at 7 seconds, what will happen? Torque is reducing. No, I don't know. Yeah, torque is reducing to, I think, minus 5. Let me check. So that what happened? Power transferred to the motor will be power transferred to the battery will be less. The reason is power production is less. Yeah. Then now torque is now minus 5. So automatically what will happen? Load torque is reduces. Load torque input to the motor is generator is reduces. So what happens? Speed will also reduce. The speed is also reduces. At the same time, that here the duty cycle is 0.8. Duty cycle is 0.8. Then here the armature current will start to increase. Then the electromagnetic torque will also reflect this. So now here what happened? The load torque, even though minus 5, we have to apply the load, the torque, the duty cycle of 0.8. So on time is more. So armature current will increase. Load current will increase. That is why it is in. sorry, I'm extremely sorry. So here minus. So armature current is initially minus, approximately 20. Then again it will reaches to again 20. The reason is we have not changed any load torque. Then again we have reduced the load torque. Due to that, what happened? Current also reduced. Current direction is reversed due to the zero reference. I have unknowingly told. Then again speed will again armature current reduces as long as torque is reduces. Then speed what will happen here in this case, here the torque is reduces, input torque is reduces, automatically speed will reduce, generator speed will reduce as the torque is reduces. So that electromagnetic torque is what happen here, electromagnetic torque also reflecting the armature current. Then what about our battery? Let me see the battery. In this battery, what happened? This is current and voltage. Current is varying with respect to load and speed. Just to analyze yourself, current and speed is varying. Then the voltage is maintained constant. See that state of charge is start to increase. Initially, state of charge is 50%. Then slope is increasing. The reason is power input is more. Then again, what happened in this case? Duty cycle we have. At the 3 seconds duty cycle, we have increases to 0.8. Therefore, what will happen? Input to the battery is reduces. Therefore, slope, state of charge, slope is different. Again, coming down. Then again, load further reduces. Input to the motor torque reduces. Again, slope of increasing the state of charge again further reduces. So this is the state of charge. Then about the power production. If you use this formula, just to calculate this formula, this is for terminal voltage. This is a supply voltage. This is supply voltage. So this is supply voltage, terminal voltage. If you substitute this power formula, you will get this values of power for various time period of changing duty cycle. See now this is initial, first one is volt current. Second one is voltage, then power. Initially power production is more. The reason is duty cycle is less. So power production is more. Power feeding to the motor, the battery is more. Then again duty cycle reduces, automatically power feeding to the battery reduces. Then in this case input torque itself reduces. Input of the generator, automatically power reduces. If you use this formula, you can automatically understand how we can go ahead with it. I hope this is from this. I want to conclude this presentation. I hope it is very much helpful to you for betterment of doing some BTech students and MTech students, just doing some analysis, which is very much helpful to you. Those who have interested and those who have liked very much, kindly subscribe this channel and give a comment on it for the betterment. And even though positive comment or negative comment, whatever it is, kindly send me the comment so that I can rectify further or I can improve further for the betterment of this channel as well. So also improvement of the society. Wish you all the best. Have a nice day. Thank you.